welcome to Cambridge Chemistry channel. You are required to subscribe the channel and like the video. So question number 5 of 2018 May-June paper 1-2. The gases X and Y react to form Z. 1 mole of X plus 1 mole of Y to form 1 mole of Z. This is the equilibrium reaction. This is reversible reaction. An equilibrium mixture of these three gases is compressed at high temperature, mean by increasing pressure at constant temperature. What will be the changes in the mole fraction of Z and in Kp? Changes in Kp increases by increasing pressure. Kp is only temperature dependent. It does not affect by increasing the pressure or temperature. It is only temperature dependent. So by increasing pressure there is no change. It can be. Now come to the mole fraction of Z. What will be the change in the mole fraction of Z and Kp? Kp, in case of Kp there is no change by increasing pressure, but in case of mole fraction of Z, let's see the chemical equation. 1 mole of X react with 1 mole of Y to form 1 mole of Z. So by increasing pressure, volume of gas is decreased, and mole fraction of the molecule, proportion of the mole particles now the number of moles of reactant is 2. This is 1 mole, this is 1 mole, this is 2 mole, and this is 1 mole. What will be the change in the mole fraction of Z and in Kp? Number of mole fraction is 2 on the reactant side, while the number of moles of 1 on the product side. At higher pressure, when the gas is compressed, the equilibrium will shift forward as there is less number of moles, but mole fraction is going to increased. So this is the best option. Mole fraction of Z will increase because there are more particles of gas on the product side, and products are increased, yield is increased, so we can say that mole fraction of Z is increased. Which gas is likely to deviate most from ideal gas behavior? So in case of HCl has no in case of now the ideal gas is the one that has no intermolecular force of attraction or repulsion between its molecules, and in ideal gas there is no loss of energy upon collision. Now the gas that would have intermolecular forces and loss of energy would be the one that is deviating from the ideal gas behavior. In this question we can see that we have HCl. Hydrogen chloride is hydrogen carrying partial positive charge, carrying partial negative charge. So this is the polar molecule and have strong intermolecular forces, permanent dipole forces, IMF forces. So this is non-ideal gas. So it deviates most. Now helium is ideal gas because it is non-polar. Molecular mass is 4 and CH4 is also non-polar. This is also non-polar. And as there is no electronegativity difference between the carbon and hydrogen, so therefore this is non-polar molecule as the number of atoms are greater as compared to helium, so it will deviate a little bit from ideal gas behavior, but as there are no charges present, so therefore the deviation will not be the most in C, and nitrogen is the molecule ID forces, weaker forces, so that's why nitrogen AR is 28 and CH4 is 16, so molecular mass is more than the CH4, so it deviates little bit more than but deviate most from ideal gas behavior, that is HCl. Question number 7, the enthalpy change of reaction is minus 114 kilojoule per mole, and this is the question. Sodium hydroxide. This is a reaction in which we can see that 2 moles of sodium hydroxide react with 1 mole of sulfuric acid to form sodium sulfate and 2 moles of water. This is reaction 1. By using this information, what is the most likely the value for the enthalpy change of reaction 2? So this is barium hydroxide plus 2HCl to form BaCl2 plus 2 water, and this is reaction 2. If the enthalpy change of reaction is minus 114 kilojoule per mole, so this is the same reaction like this is the 2H negative, 2H positive to form, this is ionic equation for this molecule, for this chemical equation, and this is ionic equation for this reaction. So the both reactions are same, so the enthalpy change of reaction 2 is also minus 114 because 2 is common and 2 is cancelled out, and both have same ionic equation, so that's why it has both are neutralization and both have same ionic equation, so that's why its enthalpy change of reaction 1 and 2 are so same, which is minus 114. Question number 8, sulfur reacts with concentrated nitric acid in a redox reaction. We have sulfur and nitric acid to form sulfur dioxide, nitrogen dioxide and water. What are the change in oxidation number of sulfur and nitrogen in this reaction? Sulfur in the form of element, so the oxidation state of sulfur is 0, and in this reaction sulfur dioxide is equal to 0, sulfur x 2 minus 2 is equal to 0, x minus 4 is equal to 0, or x is equal to 4. So plus 4 on sulfur, and similarly in case of nitrogen dioxide is equal to 0, and is x plus 2 minus 2 is equal to 0. So x is equal to plus 4. So this is plus 4 and this is plus 4. The change in oxidation state of sulfur is plus 4. Now looking at nitrogen, we have plus 4 oxidation state on so when we this is 0 to 4. So in case of sulfur plus 4 and plus 4, when we can see nitric acid and nitric acid 0 1 x 3 minus 2 is equal to 0, x 3 to the 6 and x minus 5 is equal to 0, x is equal to plus 5. So this is plus 5 and plus 5 to plus 4. The change in oxidation state is negative 1. So answer is therefore minus 1. So this is correct option. This is incorrect. Question number 9. Materials can be classified by their chemical structure. 4 common types of structure are metallic, ionic, simple molecular and giant molecular. And molecular, some physical properties of 4 substances are shown in the table. Which substance has simple molecular structure? Now we know that in simple molecular structure weaker intermolecular forces are present, so therefore the melting point and boiling point should be low. Ionic and metallic bonds have high melting point, so therefore for simple molecular structure the melting point could be, simple molecular structure could be 64, 113, 767 is for ionic bond, and similarly this is melting point, low melting point, effect of adding water. Now look at the structure of water. Effect of water, which substance has a simple molecule? These two are simple molecules. And effect of adding water, reacts with water, yes. Electrical conductivity, good when solid. This is incorrect. 113, effect of water, simple molecules are insoluble in water and always poor electrical conductivity, so B is correct answer. C 767, so this is for ionic compound, because ionic compounds have high melting point, soluble, good when solid, good when solid, soluble, not always soluble, and insoluble in water, always poor. So has simple molecular structure is B. Question number 10. In a particular reversible reaction, the yield of product is increased. if the temperature is increased, if the pressure is decreased, which equation could describe this reversible reaction? If the temperature is increased and if the pressure is decreased. If pressure is decreased, the reaction will favor the side with more number of moles. If temperature is increased, in case of exothermic reaction, it will move backward. If temperature is increased, the reaction will shift backward if the reaction is exothermic, and less yield is produced. Less yield. If the pressure is decreased, the reaction will favor the side with more number of moles. If on the product side has more number of moles, so which equation could describe the reversible reaction? So it means if pressure is decreased, more number of moles. More number of moles. So if the pressure is decreased, more number of moles, reaction will favor the more numbers. It means the product side must have more number of moles. So yield is increased. So now look at the which equation could describe this reversible reaction. CH4 plus water, this is endothermic reaction. By increasing temperature, the reaction will favor the endothermic side, so more yield is produced. So in case of temperature, this is correct. Now look at the in case of pressure. By decreasing pressure, there must be more number of moles on the product side. Now 4 moles of ammonia react with 3 moles of 1 mole of methane react with 1 mole of water to form 3 moles of hydrogen. 4 moles are there. Over here 2 moles, on this side 4 moles. So it means by increasing pressure, reaction will favor the forward side, more yield is produced. By decreasing pressure, reaction will favor the forward or will favor the right hand side, so more yield is produced. So this option is correct. Now look at here, 4 moles, over here 3 moles, 7 moles, and over here 8 moles. So in case of pressure, this is correct, but in case of exothermic, this is exothermic reaction, so reaction will favor backward, so less yield is produced. So over here 1 mole, over here 2 moles, less number of moles on the product side, this is incorrect. 1 mole on product side and 2 moles on reactant side, so this is also incorrect. 2 moles on this side and 3 moles on this side. Reaction is endothermic in case of by increasing temperature, this is correct, but in case of number of moles, this is incorrect. So A option is correct. Question number 11. A chemical company used a catalyst in a chemical process. The company has now decided not to use the catalyst but to increase the temperature so that the rate of reaction is the same as it was when the catalyst was used. Reaction is same when the catalyst was used. Which statement about the new conditions compared to the original condition is correct? Which statement about the new conditions compared to the original condition is correct? the activation energy has been decreased. Yes, in case of catalyst, activation energy has been decreased, but new conditions, catalyst, there is uh, catalyst absent but increase the temperature. So this is incorrect because activation energy has been decreased, but in the absence of catalyst, activation energy has been increased. The activation energy has been increased in the new condition. So in the absence of catalyst, activation energy has been increased, so it is correct. There are fewer successful collisions per unit time. Fewer, there is, because in case of catalyst, see, there are fewer successful collisions per unit time, as we can see that in the new conditions we have increased the temperature and removed the catalyst, so therefore there is no effect on successful collision. So this is incorrect, and this can also be seen from the fact that the rate of reaction is the same as it was when the catalyst was used. So when the rate of reaction is same, this number of successful collisions will also be the same. So this will not be fewer or more. The answer D option is also incorrect, so B is correct option. Which oxides does not react with cold dilute sodium hydroxide to produce a salt? In the option we have aluminum oxide. Aluminum oxide is amphoteric oxide. Amphoteric oxide. So it can react with both acids and alkali to form salt and water, which does not. So that's why it is incorrect. P4O10 is the acidic oxides, does not react with cool dilute sodium hydroxide, which is acidic oxide. It is acidic oxide. So also react with sodium hydroxide to form salt and water. So this is also incorrect. Sulfur dioxide is also acidic oxide. So it is it can also react with dilute sodium hydroxide to produce salt. So silica, option C is also wrong. So D is silica. Now silica is not much reactive, so therefore it cannot react with cold dilute sodium hydroxide. It will react with concentrated, not much reactive with cold dilute sodium hydroxide, can only react with concentrated sodium hydroxide, concentrated hot. So that's why D is correct option. Question number 13. The graph shows trends in 4 physical properties of elements in period 3 excluding argon. Which graph has electronegativity on the y-axis. Question 13. Now electronegativity is the tendency of an atom to attract a shared pair of electrons towards itself. For example, when hydrogen and fluorine that make a bond, fluorine is more electronegative, so this pair will be attracted towards fluorine. That's why fluorine becomes partial negative and hydrogen becomes partial positive. Which graph has electronegativity on the y-axis? So generally electronegativity is going to increase across the period. So this is going to decrease, so that's why B is incorrect. This is first increase, then same, then and then decrease. So this is also incorrect. So C option is also incorrect because this is not a general trend. Increase, decrease, increase, decrease. So electronegativity is going to increase, generally increase across the period. So first sodium is positive, electropositive, magnesium is electropositive, aluminum is electropositive, plus 4, this is electronegative, minus 3, minus 2, minus 1. So chlorine is most electronegative element. So along the period, in period 3 the atomic size decreases, because atomic size decreases, so therefore electronegativity will increase. The nuclear charge increases as the number of protons in the nucleus increases, so therefore electronegativity will also increase. So the only graph that represents the increase in electronegativity is D. As we can see that the electronegativity of sodium is lower than the magnesium, than the aluminum, then silicon, and then phosphorus. So that's why D option is correct option. Question number 14. In this question, X represents an atom of chlorine, bromine, and iodine. Which explanation for the variation in volatility down the group 17 is correct? We know that in group 17 what happens, that the electron elements become solid from gas, because we have 3 states of matter in this group. First fluorine, chlorine, bromine, iodine. First 2 are gases, then liquid, and iodine is solid. Astatine is also solid. So therefore the intermolecular forces increase and volatility decreases. We have instantaneous dipole induced dipole force between the molecules becomes stronger and stronger as there are more number of electrons. Down the number of electrons are going to increase, and size of atom is also increased. So there is true statement, because the instantaneous dipole forces are increased between the molecular becomes stronger instantaneous, because this is the simple molecule and they have id forces. So instantaneous dipole induced dipole forces between the molecule become stronger as the size of atom is increased and number of electron is also increased. Permanent dipole forces are not present between the halogen molecules, so this is incorrect. The bond energy of X2 molecule decreases. Bond energy of the X2 molecule increases as the bond length X decreases. Bond energy of the X2 molecules decreases. Sorry, this is incorrect. This is not correct. Instantaneous. Which explanation for the volatility? For the variation in volatility. the bond energy of ideal forces. So part C, the bond energy of the X2 molecules decreases. This is true statement because the bond energy of the fluorine is very high. Bond energy of the fluorine is very high as compared to the bond energy of iodine. This has nothing to do with the volatility, as volatility does not depend upon the bond energy. Volatility does not depend on the bond energy. This is very important to learn, bond energy. So it depends on intermolecular forces, so C is also incorrect. A is correct option. The first ionization energy X to X plus E electron decreases. This is also incorrect. The removing of electron, it does not have anything to do with the intermolecular forces of reaction, so D is also incorrect because the first ionization energy is X gaseous, X positive ions, so it does not depend on the first ionization energy, depend on the volatility. Volatility only depends on the strength of forces, and strength of forces, A option is correctly explains the volatility, variation in volatility down the group, so A option is correct. Sorry. The manufacturer, question number 15, the manufacturer cement 1000 million tons of limestones are decomposed each year. To manufacture lime for agriculture, 200 million tons of limestones are decomposed each year. What is the total mass of carbon dioxide in million tons produced from these two processes in a year? Total mass of we will use grams for this 1 gram. We will use grams for 1 gram for this 1000 and million tons, and we use grams. So this is total 1200 grams. 1200 grams of limestones are decomposed each year. What is the total mass of this? Is 12,000 calcium carbonate to form calcium oxide plus carbon dioxide. So this is 12. Find out number of moles. 1200 divided by 100, this is equal to 12 moles. So what is the total mass of carbon dioxide? 1:1 between calcium carbonate and carbon dioxide. So if 12 moles of carbon dioxide, ratio X, so moles of carbon dioxide are 12, mass of is equal to 12 into 44, so equal to 528. So this option is correct. Question number 16. Question number 16, group 2 of the periodic table. The properties of in group 2 of the periodic table, the properties of elements and their compounds show regular change down the group. Which property shows decrease from magnesium to barium? The decomposition temperature, magnesium to barium. Decomposition temperature is increased down the group as the size of cations increased. So more temperature is required to decompose barium carbonate than magnesium carbonate. So this is incorrect. The decomposition temperature of the nitrate is also increased. So this is also incorrect. The solubility of the hydroxide is increased. Solubility of hydroxide is also increased. So this is also incorrect. The solubility of the sulfate is decreased. So this is incorrect. Which concentrated sulfuric acid is added to solid sodium bromide bromine gases? Sodium bromide bromine gas is produced along with number of other products. However, when concentrated sulfuric acid is added to solid sodium chloride, only hydrogen chloride and sodium hydrogen sulfate are produced. What is the reason for this difference? Bromine is less volatile than chlorine. Bromine is less volatile than chlorine. This is correct, but this is not the reason that concentrated sulfuric acid is added to form sodium bromide bromine gas is produced. So this is not the reason. So this is incorrect. Hydrochloric acid is a weak acid. So hydrochloric acid is a strong acid. So this is also incorrect. Sulfuric acid is not an oxidizing agent. Sulfuric acid is an oxidizing agent and oxidizes sodium chloride and sodium bromide to form hydrogen chloride and sodium hydrogen sulfate. But hydrogen chloride is strong oxidizing agent than sulfuric acid, so that's why it is not further oxidized. But sodium hydrogen bromide is weaker oxidizing agent than sulfuric acid, so that's why it is further oxidized to form solid sodium bromide bromine gas and other products. So this is also incorrect. Sulfuric acid is an oxidizing agent. The bromide ion is strong oxidizing agent. Yes, bromide ion is stronger reducing agent than the chloride ions. So that's why, because down the group reducing power of halide ion is increased. So D option is correct. The dative covalent bond can be represented by the arrow. The arrow points towards the atom receiving the lone pair of electrons. So the hydrogen is electron receiving. So arrow towards the hydrogen atom, arrow towards the nitrogen atom. So this is arrow directed towards the hydrogen atom which is receiving. So that's why this is incorrect. This is correct, but this is incorrect. This is This is incorrect. Arrow towards the hydrogen atom, electron towards the hydrogen atom. So lone pair of electrons. So this is the arrowhead towards the hydrogen atom. So this is correct, this is incorrect, and hydrogen positive ion is also correct. So C option is correct. This is incorrect, arrow is correct. Sulfur dioxide can be catalytically oxidized by oxide of nitrogen in the atmosphere. Which reactions shows the regeneration of the catalyst? Sulfur dioxide can be catalytically oxidized by an oxide of nitrogen in the atmosphere. This is the sulfur dioxide can be catalytically oxidized by an oxide of nitrogen NO2 to form SO3 plus nitrogen monoxide. So nitrogen monoxide is further oxidized in atmosphere to form nitrogen dioxide. So nitrogen dioxide is regenerated in this reaction. So D option is correct. Question number 20. Compound Y is treated with an excess of hydrogen gas in the presence of a nickel catalyst. The product is fully saturated. The product is fully saturated. What is the number of chiral carbon atoms in the product? So this is double bond, not chiral carbon atom. This is not, this is chiral, this is chiral. This is again chiral carbon atom. 1. This is chiral carbon. 1, 2, 3. C3. 1, 2. What is the number of chiral carbon atoms in the this is double bond is when hydrogen gas in the presence of nickel catalyst. So removing double bond. So this is chiral carbon. This is chiral carbon. This is chiral carbon. 1, 2, 3, 4, and this is chiral carbon. So 5. Which equation represents a valid propagation step in the chlorination of ethane? C2H6 plus Cl. So hydrogen is not produced in the propagation reaction. Cl is produced C2H6 C2H5Cl. So hydrogen is not produced in the propagation step. So this is incorrect. C2H5Cl, Cl. This is free radical, make this compound free radical, and hydrogen is react with chlorine to form HCl. So this is correct. Again, hydrogen is not hydrogen cannot be, because chlorine is produced